Good morning, students. Today we are going to study the last part of the lesson, gravitation. Okay, so today we are going to study about few points. These are mass and weight, gravitational potential, and escape velocity. Okay, these were the points which were left to study. So first we'll study about the mass and weight. So usually we think that there is no difference between the mass and the weight. Okay, but the answer is no. The answer is yes. There is a difference between the mass and the weight. So what is mass? So mass is the amount of the matter in an object. Okay, so you can see here, if the object is small, the number of the molecules in the object is very less, and if the object is little bigger, the molecules are more. That means the mass of the one object is less and the mass of the another object is more. So what is the definition of the mass? Mass is the amount of the matter present in an object. Now this mass is same everywhere. Okay, it does not change. So for example, if you take a ball, okay, if you take the ball, if you place the ball on the earth, okay, the number of the molecules in that ball is same. Okay, it is, suppose there are 100 molecules in the ball. Okay, now if you carry the ball on the moon, so the number of the molecules in the ball will not change. It will be same, it will be similar, it will remain constant. Okay, so here the mass value is same everywhere. It is the value of the weight which is changing when you change the place. Okay, but the value of the mass does not changes. So two things we studied. First is the mass is the amount of the matter. Second is mass is same everywhere. Okay, the unit of the mass is kilogram. Then the usually the mass means what? It is a measure of the inertia of an object. So higher the mass, higher is the inertia. Okay. Now next we will study about the weight. So weight means what? What is the weight? It is actually the gravitational force acting on an object. The weight of an object is defined as the force with which the earth attracts the object. Okay. You are standing on the weighing machine and you weigh your weight. So it is actually the force of the gravitational force. So I have given you the example of the ball. If you place the ball on the earth, the weight will be different because the force is different. If you place the ball on the moon, there the weight of the ball will be different. It will change as you change the place. Mass does not change with the place, but weight changes with the place. Okay. So what is the formula to find out the weight? Weight is what? The force of the gravity. Okay. So weight is equal to force. And what is the formula of force? Force is equal to mass into acceleration. Now in this lesson we are going to take acceleration as g. So here it is written as W is equal to F is equal to mg. And what is the value of g? G is equal to gm upon r square. This you will get on the page number 8. Okay, when we were studying about the Earth's gravitational acceleration. So this is the value of, this is the formula to find out the weight. Weight is force. Now, if the weight is force, then what is the unit of the weight? What is the unit of force? Unit of force is Newton. So the unit of the weight is also Newton. So the unit of mass is kilogram and unit of force is Newton. Okay, and weight will change according to the place. It will not remain the constant. Okay, now the main important point which you have to keep in mind or memorize, it is that the value of the weight of any object on the moon is about 1/6 of the weight of the earth. Now what is the meaning of this? So if you get a question in your paper or in your book that if your weight is on the earth is 60 kilo, or sorry, it is in Newton, okay, sorry, it is by mistake, it is in kilo, it's Newton, so 60 Newton. So what will be the weight on the moon? So if you want to find out your weight on the moon, so you have to divide by 6 because it is 1/6. Okay, 1/6 part is 10. It's 10 Newton. By mistake it is written as kilo. It is 10 Newton. Okay. Now let us see the difference between the mass and the weight. So first is the pull of the Earth's gravitational force on the object is weight. Weight is what? The Earth's gravitational pull. And what is mass? The amount of the matter present in the object. Second is weight changes according to the places and mass remains same. Third one is you can write about the unit. This SI unit is Newton and the mass units is kilogram. Then the measured you can measure the weight by using the spring balance or the compression balance, and mass you measure by using the lever balance, okay, or the electrical balances which are available. Now next point we'll study about the gravitational potential. What is potential energy? The energy which is stored in an object is called as the potential energy. Now we are studying about the gravitational potential energy, okay, of the earth. Now one thing you have studied first earlier, that if any object goes higher and higher than the earth's surface, then the value of the gravitation or the value of the G becomes 0, okay. Okay, after that, now if you go at the higher place height, okay, then it is 0. Then if the object comes nearby, okay, near or smaller, the height will be smaller, then what will be the value of the potential energy? So it will be less than the 0. If it is 0 at the higher place, okay, so if you come down below, then what will be its value? It's the value of the potential energy will become negative, okay, it will become negative when the height is bigger. Here in your textbook it is given the formula, that is minus gmm upon r plus h, where m and r are the masses and the radius of the earth, mass and the radius of the earth. So negative gmm upon r square. Now we'll study about the last point, that is escape velocity. Very interesting point. Now we have studied that if you throw any object up, okay, it will reach a certain height and will stop there. This velocity will become 0 and immediately it will start coming down fast, okay. Now if you throw a ball up with a certain initial velocity, okay, it will come down. Now if you increase your initial velocity, okay, little fast you are throwing up, so again the ball will come down, okay. Now you increase your velocity more and more, okay. So what will happen here? It will go up a certain height and again come down. Now if you increase the velocity so much that the object is escaping from the Earth's atmosphere, it is not coming down, it doesn't come down, okay. So this velocity where the object escapes the earth forever and will not come back in the earth, this velocity is called as the escape velocity, okay. Is it clear? So the velocity by which the object escapes the gravitational force of the earth. Now your initial velocity must be how much? Okay, it should be how much? It should be 11.2 kilometer per second. And if you want to calculate the escape velocity, then what is the formula for you? It is the under root 2 gm upon r. In textbook it is given as capital R. So usually when you have to calculate the escape velocity, you have to use this formula. It is under root 2 gm upon r. You can read the page number 14. You will understand how it is, okay. But from this you understand that the escape velocity should be 11.2 kilometer per second. Means for 1 second it should cover how much distance? It should cover 11.2 kilometer, okay. Such a high velocity. Now when the satellites are sent or the launched, spacecrafts are sent to the moon or the other planets, they should have the initial velocity larger than the escape velocity. It should not be less than the 11.2 kilometer per second. It should be more than the 11.2 kilometer per second, okay. So then only this object will escape from the earth's surface. Otherwise what will happen? The object will come back on the earth, or the earth's gravitational force will pull the object back on the earth. It will not go out, it will pull. So if you have to throw, or if you want to throw, or if you want to launch anything out from the earth's surface, then your initial velocity should be more than 11.2 kilometer per second, okay. So in this lesson we studied about the mass and the weight. then the gravitational potential, and the escape velocity. You have to read the lesson thoroughly and understand the points. The numericals which you are going, which are given here, are also little very easy. Only the similar formulas are only used. Only the mathematical calculations should be done properly. So you have to read the whole lesson now, so that you can understand the different points over here which we have explained earlier. Okay, and then we will go for the exercise part.